Well, to finish up the week, this is our last day of working with rectangles, and rectangles as in a means to approximate the area under a curve, and in doing so to change the units of a problem. And we saw how more rectangles make more accuracy. There's another approach using what's called a midpoint approach that we're going to talk about today, which is another way to improve accuracy. So each day we're going to be adding something that gives us another way to get more and more accurate answers. So just to recap, what you've been doing is LRAM, and we know that the problem with LRAM is that every time a function is going up, the LRAM is always too small. There's always an underestimating of all this space here. But if we do RRAM for a function that's also going up, we know that that is always too big. So we have a problem there. So we ended up averaging the two. And then if we go the other direction, if we have an LRAM on a decreasing section, well, now this is the one that's too big. And if we have an RRAM on a decreasing section, well, now this is the one that's too small. All right, so there's problems with our LRAM and our RRAM. So we're going to add a third approach, a better way, called MRAM. And MRAM stands for middle or midpoint. And so this is in the center here. And so you can see that part of the rectangles are still above the curve, which means that part's too big. But another part of the rectangles are under the curve, which is too small, and that balances each other out and we get a much more accurate picture. It works the same when we're increasing or decreasing, whether the curve is going up or down. We have parts of the MRAM that are too big and parts of the middle that are too small. And so we're coming up with a better, more accurate than either LRAM or RRAM by themselves. So let's take this problem that we were working on the last couple days and let's see how this approach for an MRAM 3 would work. Okay, so for an MRAM 3, that means I'm doing 3 intervals using these dots. Okay, and so the lines of my rectangles are going to come down and I've got 3 to form. The thing is that I'm not going to use either the left or the right dots to form my rectangle. I am going to use the dot that's in the middle. So I've got a dot in the center here, right above 0.5, and that is going to be the top of my rectangle. And then I have a dot here in the center, in the midpoint, which is above 1.5, and that, straight across through it, that will be the height of my rectangle. And then I have a dot right here above 2.5, and that will be the height of my rectangle. So we can continue with using our rectangular calculation, so base times height. So we'll have our rectangle number 1. Now the base is still 1, but the height is found at that center. So I want to look over at my table here, and I'm looking at 0.5, so I'm looking at a height of 2.75. And then my rectangle number 2 is a base of 1, and the height is formed at 1.5. So I look at that, and that's a height of 3.75. So 1 times 3.75. And then my third rectangle, consistent base of 1, but the height right above 2.5. And so according to my table, that's 6.75. So 1 as a base and 6.75 times the height. And so then I'll add up these 3 rectangles. So I get 13.25 as my estimated area as the best approximation. Better than LRAM, better than RRAM. If you remember yesterday, we had 11 for our LRAM, we had 17 for our RRAM, so now we're looking at 13.25. It's not being the average, okay? It's not the average of the two. Okay, our LRAM was 11. The RRAM was 17. The average was 14. Okay, but the MRAM, which is the best so far that we have, is 13.25. So it's not the same as the average. In fact, it's a little lower than the average. Okay, but it's a better approximation. All right, so want to be clear on that. MRAM is not the average of LRAM and RRAM. Why not? Because we're not dealing with straight lines here. The function is curved. And so a curve doesn't mean a perfect average. A curve means part of the left is going to be a lot lower than part of the right. So because the function is curved, it is not you can't just say, oh, MRAM is going to be the same as average. Those are two different things. So MRAM is a better estimation method. So far. Right, we'll have even better ones, but so far it's the better one that we have. So how do we improve this? Well, we do more rectangles. So now we're going to do MRAM 6. All right, so for 6, I'm going to use all of these dots. So I've got 6 different columns, I guess, whatever, 6 different intervals. But for MRAM, I need to find the middle, okay? The middle is above the center here, and I need to figure out what that is. Now, the middle is not on my chart. My chart, my middle, okay, this is 0, this is 0.5. Those are both on my chart. This one is happening at 0.25, which is not on my chart. So we're gonna have to add numbers to the chart that aren't there. So we've got here, we want to add 0.25 to the chart, so let's figure out what that is, which means I need to plug in 0.25 to the equation. I need to put it into x squared minus x plus 3 and figure out what we get. So if we just take 0.25 and we square it, and then we subtract 0.25 and then we add 3, we get 2.8125. Okay, so notice that's not perfectly in between 3 and 2.75. So how does that help us find our R number 1, our rectangle number 1? So here we go. It's going to be that tall. Our R number 1 has a base that's different than what we were doing before. The base is no longer 1. The base is 0.5. The height is 2.875. Excuse me, 2.8125. So our rectangle number 1 is a base of 0.5 times a height of 2.8125. So that's going to give me, I need to actually multiply that together. So my first rectangle is 1.40625. So keep a hold of that number. All right, rectangle number 2. Rectangle number 2 will be right here, partially above and partially below. Can you see that? That it's got some gap area here, but then it also has gap area here. That's what makes it such a better estimate. So this rectangle also has a base of 0.5, but its height, if this is 1, then its height here, straight down in the middle, that's why we call it the midpoint, is at 0.75. So I need to add that to my table because I do not have 0.75 on my table. So I'm going to add between those two, I'm going to add 0.75, which means I'm going to get a number between those two. And I'm going to go ahead and plug in 0.75, which gives me 2.8125 again. So my rectangle 2 is another base of 0.5 times 2.8125. So it's the same thing for my second rectangle because they're the exact same shape. All right, rectangle number 3. That's going to be about right here. Again, partially above, partially below. Okay, its height right down the middle of this interval. This is 1.5, so this is 1.25. And so I need to go to my chart and I'm going to add 1.25 as a data point, and I need to find something that's between 3 and 3.75. So I need to take my 1.25 and plug it into the function, square it, subtract 1.25, and then add 3. This is going to give me 3.3125. So my rectangle 3 has that same base of 0.5, but its height is 3.3125, and multiply those two together, and it gives me 1.65625. Keep all these numbers straight, okay? So you just are repeating this process. We're going to find the center, the mid, a little bit above, a little bit below. It's directly above the value 1.75. This will be 2. I'm going to draw all mine right now while I've got it, okay? So this one will be partially above, partially below. And it is directly above, come down the middle here, 2.25. Zoom in on that a minute. Oops. Okay. 2.25, this will be 2.5. This will be 3, so this would be 2.75. I can come kind of straight up to where that's going to be, all the way, and find that middle. Okay, partially above, partially below. All right, and we're pretty much set here. All right, so I need to add some more data points to my values here. I need to find 1.75, I need to find 2.25, and I need to find 2.75. I need to find the corresponding y values that go with each of them by plugging them back into the function. So 1.75 squared minus 1.75 plus 3. That gives me 4.3125. How about the next one? 2.25 squared minus 2.25 plus 3. That's 5.8125. And then the last one at 2.75 squared minus 2.75 plus 3. That's 7.8125. Okay, just make sure that your numbers are between, all the other numbers you need to have. All right, so then I'm ready to do my rectangle 4, 5, and 6. So rectangle 4 will be 0.5 times 4.3125. Rectangle 5 will be 0.5 times 5.8125. Why am I multiplying by half again? It's because the bases of all these rectangles is only half wide, not 1 like it was before. All right, so let's get these values here. 3.90625 and 2.90625 and 2.15625. Okay, let's add up all these numbers. Okay, we're going to add up rectangle 1, rectangle 2, rectangle 3, 4, 5, and 6. So we want to add all of these up together. Good thing I'm not asking you to do, 10 or 20 rectangles. I'm just asking you to do this Only 6. So 1.40625 plus, again, 2 of those, plus 1.65625 plus 2.15625 plus 2.90625 plus 3.90625. All right, we get a grand total of all of that added up to be 13.4315 as our MRAM6 answer, which is more accurate than the 13.25 that we got when we only did 3 of them. We got an even better answer. So it's a little bit time consuming, but I didn't give you very many of these kind of problems. We're going to practice one more of these together. Okay, I did not give you the table of these, so you're going to have to figure out the table on your own. All right, here's an MRAM. I'm asking you to estimate the area, and I want you to go from 0 to 3. And so that means you can use 3 rectangles. So I'm going to draw them, draw the points here on my graph, starting at 0. So I've got these pieces here. Okay, those would be the 3 intervals. Because I'm doing M, okay, and I'm going to label. This is 0, 1, 2, and 3. I'm going to do an MRAM because I know now it's the best. So I'm going to find the middle and figure out how tall that rectangle is. It would be above, it would be above 0.5. Okay, and then the second rectangle, I'm going to find its height, partially above, partially below, and it's going to be above the number 1.5. And then my third rectangle, if I estimate halfway, oh, I don't know if that's so much good. Let's check. Yeah, it was a little bit off. Okay, and so then that rectangle is partially below, partially above. So I want to find out that one, and that's going to be at 2.5. So I'm going to make my own little chart here, 0.5, 1.5, and 2.5, and I want to find the heights at each of those. How do I do that? Well, I'm going to plug that number into this equation. All right, so if I put 0.5 squared and then times sine of 0.5, that gives me 0.1196. All right, let me do it for 1.5. So 1.5 squared times the sine of 1.5, 2.24436, and then 2.5 squared times the sine of 2.5, that's 3.74045. Okay, so let's keep track of all of those. Those are the heights of each of our rectangles. Okay, so this one was 0.119856. This height right here was 2.24436. And then our tallest rectangle, right about here, was 3.74045. Okay, those are the heights. So let's find our 3 rectangles. Rectangle number 1, the base though, all the way across, the whole width, don't get fooled into thinking the base is 0.5. The base is all the way across from 0 to 1. That is the base. So the base is still 1, and the height is the 0.1198. 6. And then number 2, the base of that is 1, where the height of that is 2.24436, then rectangle 3, base is still 1, height is 3.74045. All right, let's add these up to get our MRAM values. Okay, I'm adding 6.10467, and that is our MRAM estimate of the area. Okay, so what does that represent? It represents all of the area that is under this curve here. Okay, so the rectangles I used to figure out this area. Now notice I just colored it in, and some of my rectangles are too big, but some of my other rectangles are too small, so it all kind of works out in the end. And this is the value of MRAM. Okay, all right, so that was a 20-minute lesson. I hope you feel like you're ready to tackle these MRAM questions. And then this is the last day on rectangles. So we've seen how trapezoids can work, so we're going to work on trapezoids next week, and then each day be learning more accurate methods of finding area. All right, hope you have a good weekend. I'll see you on Monday.